Your robot will see better with LIDAR. The abbreviation LIDAR stands for Light Detection and Ranging, or more recently, Laser Imaging Detection and Ranging. Furthermore, in our texts, the term LIDAR is used as a generic term. LIDAR measures the distance between itself and surrounding objects either in a plane or in space. The result of the measurement is a point cloud that can be used in the navigation of robotic vacuum cleaners, autonomously guided vehicles, AGV, service robots, and the like. Principle of operation of LIDAR technology. Triangulation LIDAR. When the laser beam irradiates an object that is at the minimum measurable distance, the receiver's optics focuses the reflected radiation on pixel N. The reflected radiation from an object at the maximum measurable distance is focused on pixel 1. The distances and angles between the laser, the sensor's optics, and the sensor itself are precisely defined, allowing the use of goniometric equations to calculate the distance between the object and the LIDAR. LIDAR uses an infrared laser with a wavelength of 793 nanometers. The principle of operation shows that most of the sensor's pixels are used to measure smaller distances, so the LIDAR measures smaller distances more accurately. For example, with a sensor with 248 pixels, approximately 1200 pixels, 1 pixel equals 1.67 millimeters, are used for a range up to 2 meters, and 848 pixels, 1 pixel equals 9.43 millimeters, are available for a range of 2 to 10 meters. In a real LIDAR, the distances and angles are chosen to allow the distance measurement in the required range. For example, for YDLIDAR G4, it is 0.28 to 16 meters, with an accuracy of plus-minus 20 millimeters for distances less than 1 meter and plus-minus 2% for a range of 1 to 8 meters. A sensitive sensor can be blinded more easily. Therefore, this type of LIDAR is more suitable for indoor use with an illumination intensity of up to 550 lux. About 2000 lux, there is already a risk of damage to the sensor. The exception is the YDLIDAR X4 Pro, which also works at 2000 lux sliding, and its maximum is 40,000 lux. Time of flight LIDAR. The laser periodically emits short light pulses in the infrared region. The light reflected from the object is detected by a photodetector. LIDAR measures the time between the emitted pulse and the time when the reflection was detected. LIDAR uses an infrared laser with a wavelength of 905 nanometers. Maximum measurable distance is defined by the period t. Dmax equals 0.5 ct, and the signal-to-noise ratio. The minimum measurable distance is limited by the accuracy of the time measurement. If we compare, for example, the accuracy of the LIDAR TG30 and G4, we find out that the G4 is more accurate up to a distance of 3 meters, and TG30 is more accurate for longer distances. The photodetector has a significantly higher resistance to blinding than the sensor used in triangulation LIDARs. It typically works up to 70,000 lux and can withstand a maximum of 100,000 lux. It is therefore more suitable for working in an outdoor environment. 2D LIDARs in SOS Electronics offer. We have included 2D LIDARs from YDLIDAR in our offer. Available models can be found on our website. For more information, please visit us at soselectronic.com. Meaning of important parameters. The upper part of the LIDAR, in which the laser, photodetector, and optics are located, rotates so the field of view, horizontal field of view, is 360 degrees. The rotation speed is typically from 5 to 12 revolutions per second, motor frequency, and is adjustable using PWM or a command via the UART interface. The measuring frequency, ranging frequency is in the range of 3000 to 20,000 Hz, depending on the type, and is not adjustable. At a frequency of 3000 Hz and 6 revolutions per second, the LIDAR makes 500 measurements per revolution at 360 degrees. This results in another parameter, angle resolution. For this case, the angular resolution is 360 divided by 500 equals to 0.72 degrees. The meaning of the other parameters is obvious. How to start with LIDAR. Each LIDAR development kit contains the LIDAR itself, a converter from the LIDAR interface, UART PWM, to USB, and a USB cable. For the Windows operating system, you will need to install the VCP drivers for the CP2102 and download the LIDAR Viewer tool from the YDLIDAR website. For Linux testing, you will need to install ROS, Robot Operating System, for your Linux distribution. Download SDK and the driver source codes for a specific LIDAR from the YDLIDAR site. Compile and install them. See the user manual for details. We have extended our product offer by the YDLIDAR range of sensors measuring the distance that have the greatest potential to be successful in many current and future applications. Choose from the range of products available directly from our warehouse. We will be happy to provide you with other LIDARs upon order in a short time and under favorable conditions. You can find more technical information about the individual sensors directly on our website. Are you interested in more information about YDLIDAR products or technical advice when choosing a product? Or do you have another question or request? Please contact us at soselectronic.com. We will be happy to help you.